This is the concept quiz review for concept 17, which is series. So the first question here, part A, number 1, evaluate each of the following sums. When you look at a sum or a series, we want to first determine whether we have a geometric series or an arithmetic series. So in this case, 8 plus 8/5 plus 8/25, and so on. You can see here that each term is being divided by 5 to get the next term. So we have a geometric series. The second thing we want to look at is whether this is finite or infinite. Finite means it has a specific number of terms. Infinite means that it goes on forever. In this case, the ... here shows that it's an infinite geometric series. So we have a formula to find the sum of an infinite geometric series, which is the first term, we'll call that a sub 1, over 1 minus r. R is the multiplier or the ratio. So if we plug into that formula, here the first term is 8, 1 minus, in this case we're multiplying by 1/5 since we're dividing by 5, so it's 1 minus 1/5. So then that's 8 divided by 4/5. And then remember, when you're dividing by a fraction, we can change that to multiplication of the reciprocal. So 8 divided by 4/5 is the same as 8 times 5/4. So multiplying across here, we get 40 divided by 4, which is 10. Alright, the second one here, we have a series given in sigma notation. And looking at the expression here, we can tell that this is a arithmetic series because it has an arithmetic formula. So the formula for an arithmetic series sum would be n over 2 times the first term plus the last term. So in this case, n represents the number of terms. So if we're going from 2 to 6, you could just count. So we have 2, 3, 4, 5, 6. That's 5 terms. Or if these had been larger numbers and you didn't want to count, you could just do 6 minus 2, which is 4, and then add 1. So that's 5. First term we get by plugging in the starting value of n. So if I do that, negative 3 plus 2 times n equals 2. That's 4 minus 3, or 1. Plus the last term. The last term is when we plug in the top number, the ending value of n. So negative 3 plus 2 times n equals 6. So that's 12 minus 3, which is 9. So I have 5 over 2 times 10, which is 50 divided by 2, which is 25. Okay, the next problem is asking us to find the sum of the integers from 13 to 67, inclusive. That means all of the numbers, or all of the integers between 13 and 67, including the 13 and the 67. So we know that since we're just adding 1 each time in this series, it's an arithmetic series, so I'm going to use the same formula that we used on number 2, n over 2 a sub 1 plus a sub n. Okay, number of terms n we get by subtracting 67 minus 13. Since this is increasing by 1, each number is one of the terms. So this is 54, and then I need to add 1 onto that. So it's actually 55 terms. And then the first term is 13, the last term is 67. Okay, so here we have 13 plus 67 is 80, and then I can reduce that, so that's 40. So I just need to do 55 times 40. Okay, 2200. Okay, part C right here, which of the following expressions represents this series? So we could just work backwards here, or you can just start from scratch and write that in sigma notation. Either way would work. So in this case, if you just try to write sigma notation for this series, we know that we have 1, 2, 3, 4, 5, 6 terms. So I'm going to start at n equals 1 and go all the way up to n equals 6. And then all I need here is an expression that represents the series. So we can see here we're adding to each time, so it's arithmetic. And the initial value here would be 5, so 5 plus 2n. So if you look at these choices, I think there's actually a typo here. So this should actually be right here. Let's just change that to 5 plus 2n. And we will choose that one. Or, actually here we can see that this one is going from 0 to 5 instead of from 1 to 6. So let's see if this one actually works. So if we plug in 0 here, 2 times 0 plus 7 is 7. Okay, if we plug in 1, 2 times 1 plus 7 is 9. Okay, so it's working so far. If we plug in 2, 2 times 2 is 4, 4 plus 7 is 11. So this one actually works. So in this case it would be this one. I guess that wasn't a typo, so we'll just say it's option 2. So in that case, you could write it like this. You could also write it like this. Both are valid ways of writing it, but notice that the starting and ending values of n are different. Here we're going 0 to 5 versus here we're going 1 to 6. Alright, on part D, we have, in the first year at her new job, Mrs. Figgle-Piggle will earn $50,000 in salary. The next year she'll earn $51,500. The year after that she'll earn $53,000. The pattern continues for 10 years. What's the total amount of money she will have earned? So we're adding her salaries up. We know her salaries for the first couple years. And we know that it's going to be 10 years, and we're trying to figure out the total amount of money she will have earned. So we have an arithmetic series here. She's earning $1,500 more each year. So we can say 1,500n plus the initial value would be 50,000 minus 1,500. So 50,000 minus 1,500 would be 48,500 as our initial value. And in order to find the sum of this series, I need to use my arithmetic series sum formula. So that's n over 2 a sub 1 plus a sub n. Well, in order to find the ending term of the series, I need to plug in n equals 10. So when n equals 10, which is the last year, I'm going to calculate here 1,500 times 10 plus 48,500. So that would be 15,000 plus 48,500. Okay, so we'll just add those together. $63,500. So that's how much she makes in the last year, the 10th year. So if we use our sum formula to find the sum of all of her years of salary, 10 over 2, first term is 50,000, last term is 63,500. Okay, so let's add that up. 50,000 plus 63,500, and then multiplied by 10 divided by 2, which is 5. So $567,000 and 567,000